NEC Article 310.15 code states that medium voltage systems, which are over 1000 volts, are not subject to the continuous load provisions that are found in NEC Article 210.22. NEC Table 310.77 provides ampacity ratings for medium voltage conductors, and these ratings are not reduced for continuous load conditions. NEC Article 210.22, the one that applies to continuous load factors for conductors, is specifically limited to systems operating at 600 volts or less. Because of this voltage limitation, medium voltage systems are not covered by the provisions of NEC Article 210.22. Solar photovoltaic systems are often considered intermittent loads because they typically do not operate continuously at their full capacity. This means that the full load current, or flaw, of the transformers serving these systems does not represent a continuous load condition. Based on the ampacity ratings that are found in Table 310.77, MV105 conductors are rated for 205 amps, while MV90 conductors are rated for 190 amps. If the full load current of the circuit is 162 amps, either of these conductor sizes would be adequate for the load. To provide documentation to the authority having jurisdiction, firstly, create a written explanation outlining the points made, referencing the specific NEC articles and provisions. Secondly, include calculations to demonstrate that the selected conductors meet the ampacity requirements for the load. Thirdly, submit this documentation to the authority having jurisdiction for review and approval. By following these steps, you can make a strong case that sizing the conductors at 1.25 times the full load amps is not necessary for a 12.47 kV medium voltage system feeding photovoltaic transformers. The National Electrical Code, or NEC, provides specific guidelines for electrical installations, including those involving medium voltage, or MV, systems. Understanding these requirements is crucial for ensuring safety and compliance. One common question that arises is whether the 125% rule for continuous load applies to MV systems. This rule, which is typically applied to circuits operating at 600 volts or less, requires that conductors be sized to handle 125% of the continuous load. However, the NEC makes specific exceptions for MV systems, recognizing their unique characteristics and operating conditions. The NEC defines MV systems as those operating at over 1000 volts. Unlike low-voltage systems, MV systems are not subject to the same continuous load provisions. This is because MV systems are typically used in applications where the load is not constant and may vary significantly over time. For example, MV systems are commonly used to distribute power to large industrial facilities, commercial buildings, and renewable energy projects. In these applications, the load may fluctuate depending on the time of day, the season, and the specific activities being performed. Because of this variability, the NEC allows for conductors in MV systems to be sized based on the actual load they are expected to carry, rather than requiring them to be oversized by 125%. This can result in significant cost savings, as smaller conductors can be used, reducing the overall material and installation costs. However, it is important to carefully consider the load requirements and operating conditions when sizing conductors for MV systems. The NEC provides specific ampacity ratings for MV conductors in Table 310.77. These ratings are based on the conductor material, size, insulation type, and installation conditions. It is essential to select conductors with an ampacity rating that is sufficient to handle the expected load, while also taking into account any dirting factors that may apply. Dirting factors are used to reduce the ampacity of conductors when they are installed in certain conditions, such as in a raceway with other conductors, in a hot environment, or at high altitudes. These factors account for the increased heat generated by the conductors and ensure that they do not exceed their maximum operating temperature. In addition to the ampacity requirements, the NEC also specifies other requirements for MV systems, such as those related to grounding, overcurrent protection, and insulation. These requirements are designed to protect personnel and equipment from electrical hazards and ensure the safe and reliable operation of the system. When working with MV systems, it is important to have a thorough understanding of the NEC requirements and to follow all applicable safety procedures. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and using insulated tools. It is also important to energize and lock out the system before performing any maintenance or repair work. The NEC is a complex and constantly evolving document, so it is important to stay up to date on the latest changes and interpretations. This can be done by attending training courses, reading industry publications, and consulting with qualified electrical professionals. By following the NEC requirements and best practices, you can ensure the safe and reliable operation of MV systems and protect personnel and equipment from electrical hazards. The ampacity of a conductor is the maximum amount of electrical current that it can carry continuously without exceeding its temperature rating. This rating is determined by several factors, including the conductor material, size, insulation type, and installation conditions. The NEC provides ampacity tables for various types of conductors in different installation conditions. These tables are used to determine the appropriate conductor size for a given load. When selecting conductors for an electrical installation, it is important to choose conductors with an ampacity rating that is sufficient to handle the expected load. This means that the conductor's ampacity must be equal to or greater than the calculated load current. The calculated load current is determined by adding up the continuous and non-continuous loads on the circuit. Continuous loads are those that are expected to operate for 3 hours or more at a time, while non-continuous loads are those that are expected to operate for less than 3 hours at a time. For continuous loads, the NEC requires that the conductor be sized to carry 125% of the load current. This is to account for the additional heat generated by the continuous operation of the load. For non-continuous loads, the conductor can be sized to carry 100% of the load current. However, it is important to consider the potential for future load growth when sizing conductors. It is generally a good practice to select conductors that are slightly larger than necessary to allow for future expansion. In addition to the ampacity requirements, the NEC also specifies other requirements for conductors, such as those related to insulation, overcurrent protection, and grounding. These requirements are designed to protect personnel and equipment from electrical hazards and ensure the safe and reliable operation of the electrical system. When working with electrical conductors, it is important to have a thorough understanding of the NEC requirements and to follow all applicable safety procedures. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and using insulated tools. It is also important to energize and lock out the circuit before performing any maintenance or repair work. The NEC is a complex and constantly evolving document, so it is important to stay up to date on the latest changes and interpretations. This can be done by attending training courses, reading industry publications, and consulting with qualified electrical professionals. By following the NEC requirements and best practices, you can ensure the safe and reliable operation of electrical conductors and protect personnel and equipment from electrical hazards. Medium voltage systems operating above 1000 volts have specific considerations under the National Electrical Code, or NEC. Unlike systems operating at 600 volts or less, the requirements for continuous loads differ significantly. Understanding these differences is crucial for safe and compliant electrical installations. One key difference lies in the application of the 125% rule. For circuits operating at 600 volts or less, conductors must typically be sized to handle 125% of the continuous load. This accounts for the heat generated by prolonged operation. However, the NEC does not universally apply this rule to medium voltage systems. NEC Article 310.15 Code clarifies that the continuous load provisions of Article 210.22, which mandate the 125% rule, do not apply to systems over 1000 volts. This means that, in many cases, conductors in medium voltage systems can be sized based on the actual load they are expected to carry, without the additional 25% margin. This can lead to significant cost savings, as smaller conductors can be used. However, it's essential to carefully analyze the load characteristics and operating conditions to ensure adequate conductor sizing. The ampacity of medium voltage conductors is determined using NEC Table 310.77. This table provides ampacity ratings for various conductor types and sizes, considering factors like insulation temperature rating and installation method. The ampacity rating represents the maximum current a conductor can carry continuously under specified conditions without exceeding its temperature limit. When selecting conductors for a medium voltage system, the ampacity must be equal to or greater than the calculated load current. This calculation should consider all applicable directing factors, such as those for ambient temperature, conductor bundling, and conduit fill. Directing factors reduce the allowable ampacity to account for conditions that can increase conductor temperature. Another important consideration for medium voltage systems is the type of load being served. For example, solar photovoltaic or PV systems often present intermittent loads. These systems may not operate at full capacity continuously, meaning the full load current or flow of the transformers may not represent a continuous load condition. In such cases, the conductors can be sized based on the actual operating load, rather than the transformer's FLA. It is crucial to provide documentation to the authority having jurisdiction, or OJ, to justify the conductor sizing for a medium voltage system. This documentation should include a detailed load calculation, conductor ampacity ratings, applicable directing factors, and a clear explanation of why the 125% rule does not apply. Referencing specific NEC articles and provisions will strengthen the argument. The documentation should demonstrate that the selected conductors meet the ampacity requirements for the load and comply with all applicable NEC regulations. In conclusion, understanding the specific NEC requirements for medium voltage systems is essential for safe and compliant electrical installations. The 125% rule does not automatically apply to these systems, allowing for conductors to be sized based on the actual load they are expected to carry. However, careful load analysis, ampacity calculations, and documentation are crucial to ensure adequate conductor sizing and compliance with the NEC. Always consult with qualified electrical professionals to ensure the safety and reliability of medium voltage systems. When dealing with electrical systems, it is imperative to adhere to safety protocols and regulations outlined in the National Electrical Code, or NEC. The NEC serves as a comprehensive guide for electrical installations, ensuring the safety of personnel and property. One crucial aspect of electrical system design is conductor sizing, which involves selecting the appropriate size of electrical conductors to carry the intended load. The NEC provides detailed guidelines on conductor sizing, taking into account various factors such as ampacity, temperature ratings, and directing factors. Ampacity refers to the maximum current a conductor can carry continuously without exceeding its temperature rating. The NEC provides ampacity tables for different types of conductors based on their material, insulation type, and installation conditions. These tables are essential for determining the appropriate conductor size for a given load. Temperature ratings are another critical factor in conductor sizing. Conductors have a maximum operating temperature, and exceeding this temperature can lead to insulation damage, conductor degradation, and even fire hazards. The NEC specifies temperature ratings for different types of conductors, and it is essential to select conductors with a temperature rating that is suitable for the operating environment. Directing factors are used to adjust the ampacity of conductors based on specific installation conditions. For example, if conductors are installed in a conduit with other conductors, the ampacity of each conductor must be directed to account for the increased heat generated by the other conductors. The NEC provides directing factors for various installation conditions, and it is crucial to apply these factors correctly to ensure the safe and reliable operation of the electrical system. In addition to these factors, the NEC also addresses the sizing of conductors for specific types of loads, such as motors, transformers, and lighting systems. These loads have unique characteristics that must be considered when sizing conductors. For example, motors typically have a high inrush current when they start, and conductors must be sized to handle this inrush current without overheating. Transformers can also generate harmonics, which can affect the performance of conductors and other electrical equipment. Lighting systems can have high operating temperatures, and conductors must be selected with a temperature rating that is suitable for the lighting fixtures. The NEC also provides guidelines on the installation of conductors, including requirements for conduit fill, conductor spacing, and grounding. These requirements are designed to protect conductors from physical damage, prevent electrical shock hazards, and ensure the proper operation of the electrical system. When working with electrical conductors, it is essential to follow all applicable NEC requirements and safety procedures. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and using insulated tools. It is also important to energize and lock out the circuit before performing any maintenance or repair work. The NEC is a complex and constantly evolving document, so it is important to stay up to date on the latest changes and interpretations. This can be done by attending training courses, reading industry publications, and consulting with qualified electrical professionals. By following the NEC requirements and best practices, you can ensure the safe and reliable operation of electrical conductors and protect personnel and equipment from electrical hazards.